Okay, so we're Blurred Futures, and our project is on New York Airbnb listings, listing prices, predictions. And our team consists of myself, Trisha, Xaria, Christina, Aidan, Sam, Julian, and our instructor, Deb. So, what exactly does this project do? So in our data set, there is information on neighborhood group, neighborhood type, room type, minimum number of days, and more that correlate with each other in intriguing ways. Our goal is to predict the price of Airbnb listings in New York City, which will be measured in US dollars. So why exactly this project? Currently, it is very popular to place a property on the Airbnb market to make some extra cash and even make a whole career out of it if your property is very nice. Given this trend, we were inspired to create a machine learning model that can help potential hosts and tourists alike. It can help potential hosts decide whether it would be profitable for them to place their property on the market given its location, room type, and more. As for tourists, they can use our model to verify that the renting price is reasonable. Another final justification is that this was a very viable data set for us, large enough for us to ensure reasonably accurate results, but not so large that our computers would crash.
One correlation we have found is that the number of reviews decreases with the increase in minimum nights. This shows that the longer the required minimum nights is in an Airbnb, the fewer reviews it will receive. Most people want to rent an Airbnb with lots of reviews to ensure the quality of the house, and it is a good insight to know that a lower number of reviews is acceptable if the minimum number of nights is higher.
So our next visualization is a scatter plot between availability and price. So initially we thought that availability would have a distinct effect on the price because of seasonal demand. However, we were wrong. In this scatter plot, you can see it does not matter how available the listing is, as it does not affect the price. This graph also reaffirms that the most expensive listings are in Manhattan, while the cheapest are in the Bronx.
A violin plot is used to visualize the distribution of data. The width of it relates to the frequency of data points in that region. For example, Manhattan red has a very narrow violin shape, indicating that there are not many listings with the price of the median, $141. Manhattan red had the highest median price, $141, and its $45 to $141 range had the most distributed values. Brooklyn blue had the second highest median price, $90, and the most distributed values were in the range of $25 to $90. The widest of all the boroughs, Staten Island, purple, and Queens, green, had the same median price, $75, and the same range for the most distributed values, $48 to $75, but differed slightly in maximum prices. Lastly, the Bronx orange had the lowest median price, $65, and most of its distributed values were in the range of $40 to $65.
For the most part, there were very negative correlations between the variables as seen by price and longitude, and somewhat negative correlations between the variables as seen by availability and calculated host listings. There was a slightly positive correlation between reviews per month and number of reviews. This shows the minimum, maximum, and median prices of a listing in each of the boroughs. Overall, all of these box plots are top skewed. The median is typically between 65 and 141 for the different boroughs. This further confirms that Manhattan is typically the most expensive borough as opposed to the Bronx being the cheapest borough. There are also apparent outliers for all of the boroughs that would matter for the machine learning models. The highest median listing price is the entire home/apartment at $160. The second highest median listing price is single private rooms at $70. The lowest median listing price is the shared room at $45. This shows that when renting an entire home/apartment, you will be paying more than you would be for the single or shared rooms. We isolated the above features that we saw as the most important and turned them into our own visualizations so that we can see how they affect the price of a Airbnb listing in New York City.
First, we tried a baseline linear regression model. This model basically uses a line to predict the price of the Airbnb. linear regression assumes that all features have a linear relation with the price of an Airbnb in New York City. So we can fit a line of best fit to predict future values. After testing the model with our data set, we got a root mean square error of 74, which isn't great as most of our values got to around 40, and the higher the RMSE is, the worse it is. However, it's still not terrible.
The next model we used was k-nearest neighbors. The KNN machine learning algorithm looks at data points in a testing set and predicts a price based on its similarity to other data points in the testing set. The model creates groups of similar data points and matches the input variables to one of these groups. Our model created thousands of groups out of our 43,000 data points and has an RMSE value of 43.212.
The random forest regression model uses multiple decision trees with random decisions to create outputs and trains itself on which ones work. The RMSE we got from the model was 43.8, which is pretty good, but not the best we got from any of the models. The light gradient boosting machine model, also known as light GBM, is very similar to the random forest regression model, except it uses the outputs of its trees for the inputs of other trees. Its RMSE was 44, which isn't terrible. We had better RMSEs from other models.
So next we have stacking. Stacking is a model in which a single model is used to learn how to combine predictions from contributing models to create a linear regression. We chose this model because the RMSE value of 41.595 was lower than the others and therefore more accurate.
Next, we have a 3D plot of principal components. So PCA is used to combat the issues of high dimensional data by way of dimensionality reduction. We reduced the number of columns we had while keeping 98.22% of the variance by using principal component analysis. Essentially, PCA helps find patterns in high dimensional data sets like ours. We made a 3D graph to show the reduced 3 columns and 3 principal components. We would be able to use this new data in a new model to see if the accuracy increased or decreased.
In conclusion, stacking performed the best on our dataset for predicting the price of an Airbnb in New York. Positively correlated features with price, like number of reviews per month and neighborhoods closer to Manhattan, along with negatively correlated features like minimum number of days, helped us achieve these results. So what is the significance of our project? Because we know which features are most correlated with the price, we can identify both the factors that lead to a higher priced Airbnb and also predict what it would cost to stay in an Airbnb in New York. Thank you for listening. Do you have any questions?